Hello everyone, today's subject is testing right here. So this is the circuit schematic for it. This is a soft starter. As we can see, it has this voltage divider right here. This voltage divider charges up the capacitor to about 6 volts, and when the capacitor is charged, it turns on this MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. They can come in packages like this. Actually, I think this is an IGBT. This is a standard BJT. This is better for amplifiers because it has a way higher current gain than this. This is mostly used as a switch. And then you have, when the MOSFET is turned on, current can flow through the relay coil. This is a relay. This is the same relay but out of circuit. So this is the relay coil right here. These two are the terminals. And since this is an inductor, it has a flyback diode to eliminate extra voltage spikes that will kill your MOSFET. It all goes to ground. The capacitor can discharge to ground too. And how does the relay work? So it has a magnetic pin right here, and when the relay is turned on by applying a current to the coil, it turns on from normally closed to normally open. So it's a switch. Instead of it being an amplifier or a dimmer like a MOSFET, it's an on-off. It either has a resistance of almost 0 or a very huge resistance. So let's turn our circuit on and our multimeters on. I'll put it in continuity mode right here, and as you can see, normally closed is shorted to this pin right here, but normally open isn't shorted to this pin right now. But when I apply power, you will see that it will be shorted. So first of all, I gotta crank it up to 12 volts. Good, we have 12 volts right here, and this is ground, this right here is ground, and this is power. After about 1 second, it turns on, the multimeter beeps, and you can hear the relay click. So this circuit is used when you have a solar charge controller, and that charge controller will die if you have, let's say, an inverter, and that inverter has big filter capacitors, and those capacitors act as a short circuit for 1 second, half a second, and you have this. So first of all, you put it through a resistor, and after 1 second, when the capacitors are sort of charged, you bypass the resistor with the relay. Now, I said that if you make the capacitor bigger, so this is 10 microfarads, if you make it bigger, you'll have to wait longer. I have this capacitor right here, so this is 220 microfarads, and I will put it like this. So this is the positive, okay, I'll put it here, and we will see the charge cycle. So first of all, let's make sure to not put it incorrectly and kill it, okay? And now I'll take my scope right here, put it in scope mode, and scope mode it is. Always 10x your scope. Ground my scope, put my scope here to see the charging cycle on the capacitor. And now let's connect again, give it power. So first of all, I gotta put the actual ground right here. As we can see, it's slowly charging. It's at 1 volt, 2 volts. Let's get to 3, and I think the MOSFET turns on at 4 volts because I have a good MOSFET. Yeah, 3.4 volts actually. So yeah, this is basically, and you can see discharging to ground right now. So this is basically how the circuit works. It's slow motion. This is a very nice and useful circuit. As I said, it uses mainly solar panel circuits. Also, it's used in various applications where you have big charging capacitors. That's what it's used for, to charge the capacitor. This really good MOSFET is a FQPF6N60C, and if you have problems when building the circuit, so let's say it's a dead short, it's probably your diode. I have problems because I have this really bad diodes. I ordered some new diodes, hopefully they will arrive soon, but this really good diode is very big. It's for 10 amps. It's way overkill in amperage because all the diodes died. So if it's ever shorted, your diode might die, and it's shorted to the MOSFET to ground. So it's shorted directly positive to ground. That is about it for today's video. See you next time.